singing, we will rock you. We will rock you.
Properties of calcite. Chemical formula is CaCO3 or calcium carbonate. Class is carbonates. Color is generally white or colorless, or with light shades of yellow, blue, pink, red, brown, green, black, gray, or orange. Luster. Vitreous or resinous to dull in mass form. Transparency. Crystals are transparent and translucent. Hardness. It is 3 on rhombohedron or cleavage faces, 2 to 2.5 on the base of the crystal, and on average people would say it's about a 3. Specific gravity is 2.7 on average. The streak is white. Fracture is conchoidal, but it's really hard to tell because of the perfect cleavage. And tenacity is brittle. Note the clear color and the perfect cleavage on all 3 faces, forming what is known here as a rhombohedron. Also notice that it's transparent and translucent, and the luster is vitreous to resinous. Going over the streak, as you see as Jesse applies this calcite to the ceramic plate, the streak is white. You can barely see it because it's light and the plate is white, but believe us, it is there, and it is white. Next, we have a hardness scale. The scale of 3, this should be scratched by the nail. But we have to find them. There you can see, it is scratched by the nail. Pretty awesome. The crystal system of calcite is bar 3 2 over M hexagonal. As you see by my drawing below, hexagonal is 2 angles are 90, the other one is 120, and A equals B but does not equal C. The crystal habits of calcite are the most common begin with scolenohedron, which, as I zoom in, you can tell it looks like that. The next common, the rhombohedron, which is the common shape we mostly see in calcite, as seen in the samples we've used earlier in this video. Next is the hexagonal prism, which looks like that. And then finally a pinacoid, where pinacoid isn't actually a shape, it's just saying that 2 of the faces are parallel, as you can see by this picture. And most crystal habits of calcite, they're extremely variable, with almost any trigonal form possible. So these are a few of many options.
More crystal habits of calcite. It comes in massive forms, fibrous, stalactitic, oolitic, dendritic, granular, and many more. Cleavage of calcite. It has perfect cleavage, which occurs on the 1-0-1 plane and forms rhombohedrons. It also has twinning, which is commonly twinned on the 0-1-2 plane and the 0-0-1 plane. Common twinning seen with calcite are scolenohedral and lamellar. It results in crystals with blocky chevrons, right-angled prisms, heart shapes, or dipyramidal shapes.
Optics of calcite. Class is uniaxial negative and displays double refraction on the 1-0-1 cleavage plane. And as you can tell by the optical indicatrix here, it is backwards because I accidentally drew it backwards. So we're going to actually view it like this, with epsilon sticking up, omega sticking out, and it has refractive indices as 1.66 with the omega, and on the epsilon it is 1.49. Striking features of calcite. One of the first striking features of calcite is the fluorescence. It may fluoresce red, blue, yellow, and other colors. It also displays phosphorescence, which is when after the UV light or the light source is removed, the calcite keeps color. Thermoluminescence, which is where it turns color when it's heated, or triboluminescence, which is when it turns color when it's struck or broken. Calcite also displays effervescence. It reacts with dilute acids and gives off carbon dioxide. This is an important part of the carbon cycle because marine animals use calcium carbonate for their shells, and it traps some of the carbon dioxide that would later be introduced into the atmosphere in their shells, and it also puts it in the limestone and all the stuff that results from that. So ultimately, it helps the world, or our world, from overheating because of greenhouse gases from the release of carbon dioxide. Yay for calcite!
But that was blurry. Probably say it doesn't really ever use 28. Really? Well, you use it, but you use it. Calcite
is a non-silicate. In carbonate minerals, the carbonate group is the main building block. In other words, it replaces the silicon tetrahedron, which would be in silicate groups. It's composed of sheets of flat triangles of the oxygen ion with the carbon ion in the middle, the carbonate group. These sheets alternate along the C-axis with sheets of calcium in six-fold coordination with the oxygen anion in the carbonate group, forming a framework similar to that of feldspar. Occurrences of calcite. In rock formations, it is found in all rock forms, igneous, sedimentary, and metamorphic. In igneous rocks, it forms carbonatite, which is about 99% calcite. In sedimentary rocks, it forms limestone. It's also cement in many sandstones and shales. And in metamorphic rocks, it forms marble, which, as we all know, is metamorphosed limestone. In mineral formations, it forms stalactites and stalagmites in cave formations. It forms dogtooth spar, Mexican onyx, Iceland spar, and many more formations. For polymorphs, there are two polymorphs of calcite. There's aragonite, which is orthorhombic and quite common, and then there's vaterite, which is hexagonal, and in this classification, calcite was classed as trigonal, but in our classification, we use hexagonal instead of trigonal. But vaterite is not common.
You might wonder why we're standing in front of all this construction. Well, calcite is used in building materials such as cement, mortars, limes, and glass, among other things. It's also in antacids, rubbers, and paints.
Finally, a note to dolomite. Dolomite is quite similar to calcite, other than in its chemical formula. It has magnesium, so it's calcium magnesium carbonate instead of calcium carbonate. Colors are about the same. It's often pink or pinkish, and it can be colorless, white, yellow, gray, or brown, or black. Luster, it's pearly, vitreous to dull. Crystal system, it's hexagonal, bar 3. Crystal habits, it has saddle-shaped rhombohedral twins and simple rhombs with slightly curved faces, also prismatic, massive, granular, and rock-forming. It is never found in scalenohedrons, which is what calcite is mostly found in, or it's its most common formation, which is another way to tell dolomite apart from calcite. Cleavage, it's perfect in three directions, forming rhombohedrons, also like calcite. Its fracture is conchoidal. Hardness is 3.5 to 4, which is about a little bit harder than calcite. Streak is also white. Specific gravity is 2.86, so it's a little bit more dense. Transparency, it is transparent to translucent. Class is carbonate, and it does not readily react with acid.